we get started, we're going to get started with the notes today. But before we do that, are there any questions over the homework assignments? Questions over the homework assignments? Because I did answer your question? Yeah. Okay. Don't have to graph any of the ones on 1-2. 1-1, you did need to graph the number lines, but I'm not asking you to graph the parent function and the transformations. I believe this is where we stopped yesterday. Now, we talked about vertical translations, moving a function up and down. And our general form for a vertical translation was our f of x plus k, where k is the amount we move the function up or down. And then we did horizontal translations that move the function left or right, and our general form was f of x minus h. What we're starting off today with is reflection. Now there's two ways we can reflect it. We can reflect it across the x-axis or the y-axis. Now when we reflect a function across the x-axis, the general form of this is negative f of x. Highlighter. Negative f of x. And that's the general form we're going to use to reflect a function across the x-axis. Now to reflect it across the y-axis, we're going to use f of negative x. And we're going to use these two forms to reflect the function, the given function, across these lines, these axes. Because the reflection across the x-axis is changing the y values from positive to negative or negative to positive for the function. Reflection across the x is going to do the same thing for the input values, or x values. So let's take a look at this here. So let f of x equal the absolute value of x plus 3 plus 1. We want to reflect it across the x-axis here first. So we want to write a function g. Don't want to write in highlighter. Same notes from yesterday. G of x, whose function is reflection in the x-axis. Now our denotation for reflection across the x-axis is negative f of x. Negative f of x. Inside f of x, we still just have f of x. All we've done is put a negative sign in front of it. So we can, to apply this to the function, we'll have the negative, parentheses. Now we're going to replace f of x with its function. Absolute value of x plus 3 plus 1. Questions on what we've done? Okay? Questions on the negative part or the f of x? Yeah, so we just plugged x into f of x. Now it doesn't really do anything, it just we replace the x with x. So we get the function back. So the reflection in the x-axis general form is negative f of x. We replaced f of x with what it was equal to, and we have this here. Now the next thing we're going to do is distribute this negative through. So we're going to multiply it by the absolute value first. We're not going to multiply it through it, we just multiply it by the number in front. Now since there's not a number written, it's understood to be 1, or we can just say negative absolute value of, bless you, x plus 3. Whenever we multiply an absolute value by a number or a sign, we just leave it out front. Now we still have to multiply the 1 by this negative. Since it was positive, it's going to become negative. Questions on what we just did? Questions? Because that's it. Because for this reflection across the x-axis, really we're just multiplying each of the terms by -1, and we're done. Questions on A? B, write a function h of x, whose graph is a reflection in the y-axis. So our f of x function, I'm going to write it again. This is what we started with f of x. Now, this time we want a reflection in the y-axis. Again, I'm just referring back to these forms to help me see how it's being applied to the function. Now, reflection in the y-axis, the general form, how we state this transformation is f of negative x. That's just the general form for reflection in the y-axis. Questions on this so far? Now, unlike A, we don't have just f of x anymore. We have f of negative x. We changed the x in this notation to negative x, yes? So for our function f of x, since we changed this x to negative x, it means this x here also has to change to negative x, yes. So when we apply this transformation to it, we still have the absolute value bar. That x inside the absolute value is not going to be positive x. We are changing it to negative x plus 3 plus 1. Because in our function notation, that f of x, since we changed it to f of negative x, it means every x in the function also has to change to negative x. Almost. Do we need the parentheses anymore? There's not a number in front of it. Nothing's going to be applied to that negative x. So we could drop those parentheses. So one way is we could just rewrite it. Negative x plus 3 plus 1. The other way is we could have just erased those parentheses. Got the same thing. Questions on this here? We're going to do at least 2 more of these reflections. When we look at this next one here, write a function h whose graph is a reflection in the x-axis of the graph of x. Now, how you name them, is even on the homework test, I am not caring, because it's just a way to name it. It's a way for us to signify which function's which. So if you called it h of x, g of x, z of x, m of x for this here, even though it does say h of x, that's not what I'm looking at. I'm looking at what it's equal to, what the function is. Now for this here, it told us to write a function h whose graph is a reflection in the x-axis. Our general form for a reflection in the x-axis is negative f of x. And again, we're using f for this part because we're applying it to the function f of x. Now we have the negative in front, but f of x is still just f of x. It's still referring to that function. So we can replace it with what it's equal to. Our absolute value of x minus 5 minus 4. Questions so far? Now we just need to simplify this by distributing that negative through. So we're going to multiply our absolute values by the negative, giving us negative absolute value of x minus 5. Then we also have to distribute it to the negative 4, which is going to make it positive 4. And that's it. We reflected it in the x-axis, over the x-axis. Questions on this here? Now Now we want to write a function g whose graph is a reflection in the y-axis. We'll say g of x. Now the general form for y-axis is f of negative x. That's just the general form for it. Because we're replacing the x inside that function notation with negative x. Which means for our function here, for f of x, we also have to replace the x with negative x. Well, don't really need the parentheses, so we can drop them, telling us g of x is equal to the absolute value of negative x minus 5 minus 4. That's it. How do we feel with reflections? Do we like them a little better than left or right? Yeah. Because with a reflection across the x-axis, we're really multiplying every term by negative 1. That negative will not go inside absolute values or parentheses. Because if we have the quadratic, that parentheses squared, we'll multiply it in the front. We're not going to distribute it through that parentheses. Questions on this here? We need to see another example of a reflection across x or y. Thumbs up if you feel good with this here. You feel good with this here? Someone need me to see another example? Yes? Okay. I'll do another example. Reflection in the x-axis. It doesn't give us a name for it. We can call it h of x. So again, reflection in the x-axis is negative f of x. So we have the negative out front, and we're going to replace f of x with what it is equal to, because we still just have the f of x. So we're going to have the negative, and then in parentheses our negative absolute value of x plus 2 minus 1. And again, at this point here, we're going to distribute that negative. We're going to multiply it through each term. So that negative and our negative in front of the absolute value, those are going to multiply together and become positive. So we have just the absolute value of x plus 2. Our negative in the negative 1 is also going to be positive. And that's it there. Questions on number 3? We'll go on and look at number 4. Number 4 is the last one that we'll look at here with reflections at this point. We'll call it m of x. So f of x equals 1/2 x plus 1. And it's going to be a reflection in the y-axis. And our general form for reflection in the y-axis is f of negative x. So just like before, we're going to replace every x in the function f of x with negative x. So our 1/2 x plus 1 is going to become 1/2 times negative x plus 1. Well, 1/2 times negative x, 1/2 times a negative is going to become negative 1/2 x plus 1. Now, if that x would have been x squared, we plug it in with parentheses, we can leave it there. We don't have to simplify that parenthesis out. But here, this is it. Questions on reflections? Last type of transformation we're going to talk about here is vertical stretch and shrink, horizontal stretch and shrink. I want to look at vertical stretch and shrink first. The graph y equals a f of x, a times f of x, is a vertical stretch or shrink by a factor of a, where a is greater than 0 and a is different than 1. So multiplying the outputs by a stretches the graph vertically when a is greater than 1 and shrinks it when a is between 0 and 1. Now notice it doesn't matter if it's a stretch or shrink. If it says vertical stretch, vertical shrink, we're talking about a times f of x, a times our function, where a is the amount it's stretching or shrinking. Okay? Horizontal stretch or shrink is f of a times x. The graph of y equals f of a times x is a horizontal stretch or shrink by a factor of 1 over a. Pay attention to that. It says f of a times x, where the horizontal stretch or shrink is a multiple or shrink by a factor of 1 over a of the graph. So if we stretch it or shrink it for horizontal 1 over a, we have to flip that amount. Because if we said that there was, because here when a is between 0 and 1, so the function stretches the graph horizontally away from the y-axis when a is between 0 and 1 and shrinks the graph horizontally towards the y-axis when a is greater than 1. It's a little tricky. All they're saying is that we take that value of a and flip it. We put it 1 over it. Okay? So, it'd be nice to see an example or talk about this, what it's meaning. So if it says that our value of a, the amount we're stretching it horizontally or shrinking it horizontally, when we're doing that horizontal stretch or shrink, it gives us 1/3. A is 1 over that amount. 1 over 1/3 is 3. When it talks about horizontal stretch or shrink, flip that fraction. This is the only one we actually have to do something to before we plug it in. Left and right, we just plugged it in with our sign. Here, horizontal stretch and shrink, remember we've got to flip whatever the stretch or shrink is. Horizontal stretch and shrink, we've got to flip whatever that amount is. So if it says there's a horizontal stretch or shrink of 3, we flip it 1 over that amount. But that is the only thing we have to do something to it before we plug it in. Because left and right, left 2 units, -2, because it's left 2. We're not actually having to change it. We're not having to apply something to it. It's literally left 2, -2. Up 4 is going to be +4. Down 3, -3. So let's look at this first one here. Let f of x equal the absolute value of x minus 3 minus 5. A function h whose graph is a vertical stretch of the graph by a factor of 2. Vertical stretch and shrink. Vertical stretch and shrink. A times f of x is the general form. A times f of x, where a is the amount that we're stretching or shrinking the function by. And the amount that we're stretching or shrinking this function by is 2. We're stretching this function by a factor of 2. So our value of a is 2. Vertical stretch or shrink. Whatever it says that factor is, the scale we're stretching or shrinking it by vertically, we plug it in. It's 2. We replace a with 2. Yes? Did we do anything to our f of x? It's still just f of x. Inside those parentheses, still x, yes? So just like with our reflection across the x-axis, our vertical translation up and down, we're now just going to replace f of x with its function. Absolute value of x minus 3 minus 5. Questions on this here? Now we're going to do the same thing. We're going to multiply through. So we're going to multiply this absolute value by 2. Now we're not going to multiply it through. It's not going to be multiplied with our x minus 3, just right in front of the absolute value. So we have 2 times that absolute value. But we also have to multiply that 2 with the 5. 2 times the absolute value of x minus 3 minus 10. That's h of x. That's our vertical stretch of 2. We just multiplied the absolute value in all the other terms by 2. Questions on this here? Let f of x equal the absolute value of x minus 3 minus 5. We want to write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Horizontal stretch or shrink. Horizontal stretch or shrink, you have to flip it. You have to flip that amount they gave us. Because they told us the stretch or shrink is a factor of 1/3. Really what we're doing is saying 1 over 1/3, which is 3. Or we take that fraction and flip it. So the 3 goes from the top to the bottom. The 1 goes from the bottom to, or the top to the bottom. So we have 3 over 1. Do we write 3 over 1? It's just 3. When the denominator is 1, we just write the 3, whichever the top is. Now, if we had a whole number 3 and we flipped it, it's going to become 1 over 3. If there's no denominator written, it's understood to be 1. So what that's telling us that the number that we plug in for A, we plug in for this stretch or shrink, in this case shrink, is going to be 3. Now, horizontal stretch or shrink is f of ax. F of ax is just the general form. We flip that 1/3 to get the value that we plug in for A here. And that value we're going to plug in is, I about did it, not 1/3, it is 3. I dislike the fact that the book uses A in the definition twice. The general form is y equals f of ax, and then says A is equal to 1 over. We got to flip it. But do we understand how we got the value for A and how we set it up so far? Yes. Do we have x anymore? No. We've replaced the x with 3x. So that means every x in the function is also going to be replaced with 3x. I don't know if you noticed for this one here, once we got it set up, this acted and behaved very similar to how we did this step for reflection across the y-axis, yes? Which is very similarly at this step with how we did our horizontal translation left and right. The only thing that we could do at this point here is drop the parentheses. Yeah, no, that's it. Because there's nothing in front of that 3x, in front of the parentheses around the 3x, so we don't have to distribute anything through, we don't have to simplify down. This is as simplified as it gets. Would we agree the real tricky part, quote unquote tricky part, of horizontal stretch and shrink is just remembering to flip the value of A? Because once we do that, we plug it in, we treat it like we've been doing these here. Now again, these general forms I find helpful because it gives us a way to set up the transformation and just apply it straight to that function. No matter what the function is, no matter how it's set up, we do these steps, it works every time. Questions here? Write a function g whose graph is a horizontal stretch of the graph of f of by a factor of 5. The g of x equals horizontal stretch or shrink f of a times x. F of a times x is our horizontal stretch or shrink. The value they gave us for this stretch or shrink was 5, yes? So the number we plug in is going to be 1/5. We have to flip it. We have to put it as 1 over whatever the amount they gave us for the stretch or shrink is. So that tells us, for us here, we have f of 1/5 x. Because we plug that value of a in, that 1/5, that 1 over the amount that we're stretching or shrinking. Minus 1. And we can plug it in. We can replace every x in the function with 1/5 x. We don't really need those parentheses anymore. Yes. Yes. Because horizontal stretch or shrink, it doesn't matter if it says horizontal or horizontal stretch, horizontal shrink. Horizontal stretch and shrink is going to be this flip. And it's mainly due to the properties of the horizontal stretch and shrink because we're talking about the x-axis horizontally. So we're stretching it, which for most part, general terms here, we're going stretching it, it's increasing faster along the x, which means the y-axis going up and down is going to be slower. So it's going to look like a vertical shrink. And it has some of those properties. It does have some few quirks to it. But yeah. So this is a stretch, but it's going to look like a vertical shrink. Because vertical up, down. So x minus 1 plus 2. It's going to be easier to see it graphically. Let the calculator do this here. Y equals, clear this out, clear this out, clear this out. Absolute value, x minus 1, was it plus 5? Plus 2. This is our graph, yes? Now it's going to move it a little bit and it's going to increase it wider. Absolute value, 1/5 x minus 1 so as we can see here, it is increasing faster along the x than the one in blue. It does shift it a little bit to the right, which is a little weird, but it is increasing faster along the x-axis. We're stretching it horizontally. Because if we left it as 5, it shrunk because now it's narrower along the x-axis. It is increasing faster along the y, but it's narrower along the x-axis. It is a funky transformation, but once we see what we have to do to apply it, we just flip that amount that they gave us, plug it in for a. That's it. Does that make sense? Okay. Write a function h whose graph is a vertical shrink of the graph of f by a factor of 0.25. So this is our a times f of x. Now vertical shrink, we don't have to do anything to it. It's just 0.25 times f of x. We just put that in place of a. just like we've been doing up to this point. Now again, we're going to multiply through. Or 0.25 times the absolute value. Then we become 0.25 times the absolute value of x minus 1. 0.25 times 2. What would that be? It would be positive 0.50, 0.5. Yep. Because we can put the zeros in front, 0.25 and 0.5. 0.5, 0.25 both work. If you need to use a calculator for that, that's fine. But that's it there. Questions on this here? Are we ready for the last thing? I'm skipping 2 because I feel like at this point we've seen how this works. Yep, that one and the next one. If you do have questions on it, so it should be example 4. Let G be a vertical, yep, shrink of 0.25 followed by translation 3 units up. Okay. If you notice this one here, how many transformations are we doing? 2, yes? The textbook says we're going to do it all at once, all at the same time, which is fine for some. If we're doing a vertical shrink and a vertical translation, not going to have a whole lot of impact. Good. But it's better to do it one at a time in the order that it gave it to us. So we're starting off with h of f of x. I'm going to call this first one h of x. Doesn't really matter. We're just giving it a name for this first part because the first thing it told us is we want a vertical shrink by a factor of 0.25. Vertical stretch or shrink is our a times f of x. A times f of x. Now the amount that we're stretching this by, or shrinking this by is, so we're going to replace a with 0.25. Now what is f of x equal to? X, yes? So we'll replace f of x with its function. Mm-hmm. Yes.
So it didn't give us a equation or whatever, like the other one did, so we just put x.
It did. Yeah, f of x equals x. They kind of hit it in the problem. For the equation f of x equals x. Yeah, they just snuck it in the middle, not at the front. Mm-hmm. Does that answer where we got x from? Yeah, because they just threw, instead of stating what the function was at the start, they threw it at the end. All right, now we've got to multiply these two. 0.25 times x is, well, 0.25x. We've applied the vertical stretch of 0.25. Yes? What did it tell us to do next? Translation 3 units up. What's the general form for that? F of x plus k, yes? Are we still applying it to the function f of x? No, we're applying it to the one we just did the transformation to, yes? So our final function, we'll call it g of x, is equal to, because we're moving this function up 3, yes? So we're taking the function h of x plus k. Because again, f of x, h of x, g of x is just a way to name the function, yes? We're not wanting to apply it to f of x anymore. We're wanting to apply it to the function that already has that first transformation, which we called h of x. So again, f of x, h of x is just another way to name it. What's our value of h, or sorry, k going to be? 3, positive or negative? So we're going to replace k with positive 3. Questions so far? What is h of x? 0.25x. So we're going to replace it with h of x. And well, there isn't anything in front of the parentheses, anything we have to apply to it, kind of like we've been doing. Is there any like terms here? Are there any other transformations we have to do? So we are. Mm-hmm. No. Because g of x, so we did it. Because first transformation applying the vertical stretch got us to 0.25x. Then we did our next transformation of up 3, which got us to 0.25x plus 3. Questions on this here? Now, hopefully you notice that these transformations, when we do multiple of them, it's really, we just did one transformation, got to the answer for it, then did the next transformation to it. So we're just applying one of them to it, one at a time, to get to the final answer. So it's really just what we've been doing. We're just doing more than one of them. Let's look at one more. Let the graph G be a translation 6 units down, followed by a reflection in the x-axis. We want to do these in the set order that we have. Now, the naming doesn't matter. F of x, g of x, h of x, q of x, z of x. We just need a way to name it. So give me a letter to start with. B. B of x is what we're going to call this first transformation, because our first one is going to be 6 units down. Vertical translation. So here we're still starting with f of x plus k, yes? What's our value of k this time? 6. Would it be positive 6 or negative 6? Negative, because we're going down. Yes. Yes. Now at this point here, we can plug in the function for f of x, because it's still just f of x, so we're just replacing it. We're setting what it's equal to. Do we need the absolute values? No. Yeah, the parentheses, sorry. Absolute value, yes, we do need those. Don't need the parentheses. So translating it 6 units down took us from the absolute value of x to the function the absolute value of x minus 6. Questions on this first transformation? We're going to move on to our next one. What do we want to call the next one? I know it says g of x. I'm going to ignore it. Give me a letter. T. So our next one, we can say t of x is equal to. So we're talking about a reflection in the x-axis. Normally, our notation for it is negative f of x, but we're not applying it to f of x anymore. We're applying it to b of x. Now, even at this point, as long as you know which function you're applying it to, I'm not going to focus on the naming. I'm focused on, and we're doing this so that we set it up in such a way that we know what we're doing as we apply it. Does this make sense? Because it's just a way to name it. That way, if I said that we want to look at the function b of x, we know we're talking about this one, not this one. Yes? Because if we called this f of x, and I said we want to use the function f of x, are we using this one or that one? We don't know because they're named the same thing. That's why we're giving them different names. So we don't have to point to it to say which one we're talking about. Now at this point here, we can replace b of x with its function, the absolute value of x minus 6. And again, just like with our reflections, we're going to multiply that negative 3. Negative times our absolute value of x is going to be negative times the absolute value of x. And our negative times negative 6 is going to be positive 6. That's it. Even if we had a third, fourth transformation, we still, the way I would do it is treat it one transformation at a time. Questions on any of this here? The homework. Problems 3 through 6.
So, okay, if we get to 6 weeks,
Yes,
get those first.
that is fine. So problems 3 through 6, 11 through 14, 17 through 20, 27, 29. You are not to graph any of these. I'm just having you apply these transformations to each one of these here. So 3 through 6, 11 through 14, 17 through 20, 27, 29. Also, I will not be here tomorrow. I will not be here tomorrow. So you have the entire class time to work on any of your missing assignments. I do not. If you do have homework questions, please ask. Thank you. Now, also, if you get some assignments done, I would prefer if you hold on to them, turn them in on Monday. The sub will have a folder, but prefer if you hold on to them, give them to me Monday. Okay?